All right, today we're going to go on this pretty amazing journey. We're starting with one of the universe's most fundamental secrets, that invisible link between magnets and electricity. And we're going to follow that thread all the way to an incredibly clever device that uses the secret to get, well, perfect measurements. So it all starts with this one question that just drove early scientists crazy. They'd already figured out that electricity could make a magnet. But the big question was, could it work in reverse? Could a simple magnet just sitting there somehow create a flow of electricity? What was the secret? Well, the answer is this absolutely beautiful, fundamental law of nature called electromagnetic induction. And this single idea, this one principle, is basically the invisible engine that powers our entire modern world, from the giant generators at power plants all the way down to the charger you use for your phone. Okay, so to really get this, we've got to talk about something called magnetic flux. Now, the best way to picture it is to imagine that invisible magnetic field is like a kind of wind that's always blowing. Magnetic flux is just a way of measuring how much of that magnetic wind is flowing through a certain area, kind of like an open window. Now, here's where the magic really happens. If that magnetic wind, that flux, actually changes, if it gets stronger or weaker, or even just shifts direction, bam! The universe responds by creating a voltage in any wire that happens to be in that area. And we call this generated voltage an induced EMF, which stands for electromotive force. So this whole relationship is wrapped up perfectly in what we call Faraday's law of induction. And the key thing to remember, the most important part, is that it's not the magnet itself that makes electricity, it's the change in its field. So if you want more voltage, you can wrap your coil with more turns of wire, sure. Or use a stronger magnet, that works too. But the real secret is to make that change happen as fast as possible. Move that magnet faster. Okay, so this is huge, right? We can now generate voltage. But this opens up a whole new can of worms, a totally new challenge, because it's one thing to create voltage, but it's a completely different problem to try and measure it with absolute perfect accuracy. See, the problem is there's this really subtle but super important difference between two ideas. Any power source, like a battery, has a theoretical maximum voltage it can ever produce. We call that its EMF. But the second you connect that battery to something and current starts to flow, the actual voltage you measure, the potential difference, drops a little bit. And that's because every battery has its own tiny bit of internal resistance. And this leads to a kind of observer effect, but for circuits. When you use a normal voltmeter to measure voltage, it has to become part of the circuit. And to get its reading, it has to sip just a tiny little bit of current. But the very act of it drawing that current actually makes the voltage you're trying to measure dip just a little. So you never quite measure the true, untouched value. So this presents us with this really cool puzzle, right? How in the world can you measure the true voltage of a battery, its absolute, perfect, ideal voltage, if the very tool you use to measure it changes the result? Is there some way to peek at the voltage without touching it, without drawing any current? And the solution, it's just this wonderfully clever, super elegant device called a potentiometer. It doesn't try to muscle through the problem. Instead, it gets around it completely, using a principle that is just brilliantly simple. The whole thing, the entire genius of it, is built on one simple fact. If you take a long, uniform wire and run a steady current through it, the voltage drops along that wire in a perfectly predictable, perfectly linear way. Double the length, you get exactly double the voltage drop. It basically turns the wire into a perfect, predictable voltage ruler. So here's how we actually use that principle. It's pretty cool. First, we set up our voltage ruler by running a current from a main battery across that long wire. Then, we take the battery we want to measure and we connect it through a galvanometer, which is just a super sensitive current detector, to a little sliding contact. And then, we start sliding that contact along our wire. And you just keep sliding it, until you hit that one magic spot on the wire where the voltage from your ruler perfectly matches the voltage from your unknown battery. And right at that balance point, the galvanometer needle flicks to zero. Why? Because the voltages are perfectly balanced, so no current can flow. And that is the whole point. We're getting a perfect reading of the battery's true voltage because we aren't drawing a single amp from it. It's measurement by perfect balance. Okay, so we've got this awesome tool for perfect measurement. Now what? What can we actually do with it? Well, this is where you really start to see its power as a precision instrument. Well, one of the main things you can do is compare the true voltage of two different batteries with insane accuracy. You just pop in the first battery and find its balance length on the wire. We'll call it L1. Then you swap it for the second battery and find its balance length, L2. And because the voltage is proportional to the length, the ratio of their true voltages is literally just the ratio of the two lengths you measured. It's that simple. But here's something even cooler. You can use it to find something that's usually totally hidden, a battery's internal resistance. First, you find its true voltage by getting the balance length, L1. Then you connect a known resistor to the battery, which forces it to supply some current, and you find the new, shorter balance length, L2. And just from those two lengths, you can calculate that invisible internal resistance with incredible precision. And this, right here, just brings the whole journey full circle, doesn't it? We started with this deep, fundamental law of physics, electromagnetic induction, which created a very practical problem of how to measure it. And that challenge was solved by this incredibly clever tool, the potentiometer, which works on the very principles we were trying to understand. So, if there's one thing to take away from all this, it's how science and engineering are this perfect team. A deep, curiosity-driven dive into a fundamental principle of the universe can lead directly to the invention of these ingenious tools that solve very real-world problems with just stunning elegance and precision. And it really makes you wonder, doesn't it? The universe is just filled with these invisible rules and forces, just like electromagnetism. And for every single one of them, there's the potential for someone to come along with an equally clever idea, another potentiometer, to measure it, to understand it, and to put it to work. What do you think is next?